Ready? Um, hey guys, good afternoon. Thank you very much for joining us again. This is our third in a series of panels that we've focused on the supply chain. Today's panel is actually going to focus in the manufacturing aspect of the supply chain and Industry 4.0. Before I start, just raise a hands. Has anybody heard of the fourth industrial revolution or Industry 4.0? Just want to see who knows about it, who's heard about it, who's heard about the buzzword. Uh, Awesome. I'll give you guys a little brief summary of where we stand with the Industrial Revolution, the fourth one. And I'll introduce these guys sitting here to my right. So I'm joined by Phil, Mike, Mason, and Will today. They're members of leading companies in Richmond, along with Shaco. I'm one of the partners here at Shaco. My focus is really on helping clients understand how to use mobile technology to improve their operations and employee productivity. So hopefully I could add some value, but I know these guys here sitting to my right will definitely add some value. Um, Really, one of the things that I really wanted to focus on today was the fourth industrial revolution. As I mentioned, there's actually been four. The first one was the original industrial revolution, and I won't bore you guys too much with history, but that was the agrarian revolution. It was really characterized by the arrival of the steam engine and a transition from being primarily agrarian to industrial. The second one, again, late 1800s, early 19th century, leading up to late 1900s, leading up to World War One, was the combustion engine and the arrival of the assembly line. So basically, Ford. That was really the second industrial revolution. The third one was computing and the World Wide Web. So that was one that some people still think we're living in. Other people think that we've passed, but a common consensus is that we are now in the fourth industrial revolution or the age of intelligence. Really started about a year ago, maybe 2 years ago. And the whole concept behind the age of intelligence is how well can we use data to create a virtual world to control both the physical and biological world around us. So how could we use devices, technology, and systems to control the physical world around us and eliminate or use humans to interact with those machines around us and not necessarily interact directly with the actual machines. So that's a little bit about the history about where we stand and the four industrial revolutions. Again, most people think we're already in the fourth industrial revolution, but general consensus is that we are in the age of intelligence. That being said, the industrial revolution is really about millennials and the millennial workforce. And Phil read this really interesting article a couple days ago, and it said something along the lines of manufacturing workers are retiring in droves, and about 3 million jobs are going to be vacated by 2025. A lot of that is just basically people retiring. As a result of this, a lot of the manufacturing companies that we work with are scrambling to fill that knowledge deficit and skill gap. So, from our conversations and the people that we worked with, can you please just give us an example of how these manufacturing companies that are really not naive to as this is really the fourth industrial revolution, they're probably not naive to really replacing generations. Um, how do you think they could use mobile to attract new people and replace those vacating skill sets?
Sure. So I'm Phil Naglari. I'm Director of Mobile Technology here at Shaco. So first of all, weren't millennials born like with phones in their hands? But maybe. Anyways, over the last couple years, I've had the opportunity to work with a client doing inventory management. They had older systems, so really worked with them to transition to newer through mobile technology. In fact, I was just there the other day and walking the floor, and definitely a younger group, but as they were working with the scanner and the tablets and everything, and they were really excited about using the new technology. Other people, only half of the is rolled out right now, but the people that were using it were really excited. As you mentioned, there's more vacancies than people applying or candidates. Much of that is millennials. They grew up in the digital age. They're used to phones and everything like that, so they're used to technology. You got the STEM students. They're more interested in going to Silicon Valley, Tesla or Google or whatever. Going to that manufacturing. So it is important, to showcase the mobile technology side of things. not only to attract and retain, the people, to bring them in, but also to help out with real-time decisions. Really enable people to get, the data that they need anytime they need it. Um, you know, be able to turn off, machines, be able to up resources at the, push of a button, things like that. And the really important is, millennials they come into the manufacturing, they're used to phones and everything like that. Give them something they're used to work with.
That's interesting. So I don't know if I'm a millennial or not, but I tried using paper last time we did this, and it just didn't work. So I switched back to my iPad here. So I think I'm one of those people that was kind of born with a device in my hand. But yeah, so I was actually there on the phone that just get really adjusted to using a mobile device, and that learning curve becomes so much shorter, and to really pick up that device and that application and that skill set. So I definitely see what you're saying. That being said, we have somebody that's going to read a little more into the actual machine learning and artificial intelligence piece of it, and I think that's really going to augment how mobile devices work better with some of these people. Mike, so question for you. AI and machine learning are really getting a lot of press these days. What specifically is it that's bringing the press?
Don't say hold my beer. That's even worse. So first, thank you. And just a quick overview of what we're talking about. People say, oh, AI, machine learning. It's kind of funny when I joined Notch, my daughter said, oh, you work for a robot company, because in her brain, machine learning, right, is robots learning. And in this case, for manufacturing, it actually happens to be self-learning robots. But, what we're really talking about is basically machines and software and math doing what you would do if you had unlimited time and capacity, right? So let me give you a manufacturing example. You run a manufacturing plant, you're trying to improve yield. You're going to look at reports of processes. You're going to look at machine data. You're going to tweak things and look at what changes, and you're going to iterate that process and try to improve it, right? So that's what a human's doing today. But with machine learning, you might take thousands of variables, 3,000 variables. You might take millions of rows of data, and you might ask a really complicated question like, what are the interdependencies of things that has to happen for yield to be improved, right? And so it's the same process. It's just using math and technology to solve that problem. Um, I think the key is the success of machine learning is all dependent on data. So coming from machines and devices, data is the 80% of the work. It's sort of like investment banking. People say, oh, investment banking is sexy, but your first 2 years, you're going to look at spreadsheets for 12 hours a day. If you're a data scientist, you're going to look at data all day long and before you start running your models. So you can't be good at machine learning without good data. That's one of the challenges, but if you're good at it, it enables you to do this. And the other thing to know about machine learning is that it's iterative. So unlike a report where you say, I want a report of all the defects in the last 30 days, say, out of 3,000 variables, what combinations of things cause a defect to occur during what period of time? And the person's going to not know what's going with the answer. So they're going to look at different data. They're going to throw data away. They're going to look at different models. They're going to throw models away. So I guess one of the challenges organizationally, you have to give them the freedom to be able to have that creativity. And when they finish, you're going to have to do something with the answer, which is 72% of the time these 16 things happen, then your yield goes down. Right? So it's never 100% answer with machine learning. But I think importantly in manufacturing, and I'll cover some areas later, there are 3 key areas where it's being used. It's being used in predictive maintenance. It's being used in optimization of things like yield and quality and throughput. And it's being used in entire system operations for the entire supply chain. That's the predominant uses in manufacturing.
Curveball for you. How do you think that what you just said integrates well with mobile? So how's mobile lending into real-time analytics or analysis of the data that's being processed?
Yeah, that's an interesting one. I have some experience with it, and I did some research. So the machine learning is able to look at real-time data. If you're collecting it at real time, it can give you guidance on things that you need to do. If you have a large distributed manufacturing facility, and take something like oil and gas, which I know about, is they're massive complexes, right? So crude comes in one end and some product comes out of the other end, and it's miles of stuff making that happen. Silicon also has a very complex process. You need to be able to be in front of the device you need to make the changes to. You might make it remotely. You need hands-on. You need eyes on. Walking back to your desk, solving a problem, watching it for 4 hours and coming back is not going to give you the efficiency of mobile being able to be there. But really where I see it is more in the extended supply chain. So working with your customers on order management and demand planning. I see it with working with your suppliers. So in a way that you're able to sit with them and look at real-time processes and look at defects and things like that and how the supply they're providing impacts it. So in other words, what's happening is you're enabling your workforce to sit with partners, customers, suppliers, and have a real-time conversation as opposed to looking at last month's reports. But you can also have a predictive conversation, right? Which is, if you keep doing this, this is what's going to happen for me. Let's find a way to solve that problem.
Let me do this. Let me give you back your beer.
Take care of that.
Honestly, I wish we would have done this sooner. And the next person that I want to introduce is really Mason. I think one of the things that brings all of this together and makes it doable is user experience and design. And Mason, one of the things that I really want you to bring to light with a lot of people is, why is aesthetic and user experience so critical to the entire process?
So like Alex said, my name is Mason. I'm a UX guy here at Shaco. And I think that, we're talking a lot about like the machine learning and collecting data and collecting all this information and all this really valuable stuff to manufacturing or really any industry at that. But none of it to me really matters. Yeah, nothing that you brought up really matters. I just met him. I'm sorry. That's not nice.
What matters if you can do something with it.
Exactly. No, you're totally right.
Which is
It's design. And I think a lot of what I love doing is the communication element of design. Like, are you relaying the information you need to relay at the right time? Are you giving it to the people that can actually use it? Are you giving it to the 65-year-old foreman who's been at the company for 40 years in a way that they understand, or the millennial, like, in a way that they can understand? And one thing that is so critical to that is everyone has smartphones, and like, smartphones are being built by companies that are hiring fleets of designers to build modern UX, modern UI that looks killer, that's very good. You take that experience where they're using this supercomputer in their pocket every day, and then you give them a human machine interface, an HMI in a factory that's all gray at the same font size, the same weight, same everything, and it's just obtuse and hard to use. Your company's not going to run as well because your software sucks. But bigger thing is that you could also cause someone to get hurt. You could cause someone to lose money, which they could lose jobs. Like, there is a huge amount of value behind design and how we communicate this stuff. So I think that, yes, we have all this great technology, but if we're not communicating in a way that people can use, what's the point? And one thing that I think that we're all really passionate at Shaco, and I'm sure everyone here is like finding a middle ground of, like, we have all this great information. How are we going to get it to a way that you can actually use? And it can even come down to, like, understanding that, like, hey, our work day is 7 a.m. to 3 p.m. So if I get a push notification at 8 p.m., I'm probably not going to be able to react to it. Or I need to know that if I'm getting that notification at 8 p.m., that's critical. Here's your mic.
Pass the mic. So what? Oh, Mason could drop it, but I do promise next time we will have this whole mic thing figured out. And before we do, we're gonna just increase the hype, and we're gonna go into Bitcoin. And Bitcoin does play a role in manufacturing, I think. Once I figure out what it is. So I know there's been a recent addition of Bitcoin to the Chicago Board of Options Exchange and Chicago Mercantile Exchange. First of all, Will, I need you to explain what that is. But furthermore, Bitcoin and blockchain are two terms that are used interchangeably. And I'd love to understand what the difference is, and is the hype really worth it?
I made like $300 on Bitcoin.
Nice. Yeah. So Bitcoin. Yeah. Did you sell it yet? Did you sell it yet? All right. Good. Yeah. So my name is Will Middleton. I've been in the kind of cryptocurrency and blockchain space here for the past year or so. I'm a recent chapter lead for the Government Blockchain Association, where we focus on kind of governance issues and how blockchain can help streamline some government processes. So for the Chicago Board of Exchange and the Chicago Mercantile Exchange, they're basically trading offices in Chicago that are going to allow institutional investors to now speculate on Bitcoin, whereas previously they had not been able to. So I don't know, I might sell. Yeah, that's just me. So yeah, so I think part of this is you need to separate Bitcoin from blockchain a little bit. I think a lot of people think, okay, Bitcoin, blockchain, it's all the same thing. It's not. Blockchain is one of the pieces of the underlying, like one of the underlying technologies in Bitcoin that has allowed it to thrive the way that it has. And then Bitcoin's just an application of that, right? And so at its fundamental level, blockchain allows a user to prove that, a user being like an entity, a machine, an organization, to prove that it has access and that it owns a particular piece of data. So that could be Bitcoin, for value. That could be anything, right? Like data readings for some machine at a particular time, or some tag identifier for a product moving through a supply chain, right? So I think that technology, in the manufacturing space, in combination with machine learning and UI, will really allow machines to give off sensor readings that then can be plugged into your machine learning to give you some machine learning readouts, and then allow some of your more experienced workforce to look at those readings, right? And understand, like, how do I triage this process, right? Because in the interim, like machine learning, yeah, it's pretty fast, right? But if you don't have the right data, right, then it's kind of worthless, right? So you got to have the workforce there that really knows, like, okay, we need to figure out a way to measure this high-pitched screeching sound, right, on this machine, that, like, I know that that's the thing that means this piece is getting developed correctly, right? Whereas someone who maybe doesn't have that experience wouldn't really have that knowledge or wherewithal to put that into the equation. Yeah.
Can I add 2 cents to that?
Yeah, no, please.
So one of the things you mentioned is having that level of detail. And so if you look at a supply chain, you might have, like, okay, this product hit the loading dock here, and on Tuesday it left. Well, that's great, but what time Tuesday? In a just-in-time supply chain, if you have that little provenance handoff at real time, it becomes so much more valuable for you to understand how to optimize it. Because part of data science is just like, show me lowest level of data you possibly have. And so that plus the chain of command is super valuable. So great.
Actually, can you hand it back? I'm going to try to speak a little louder, but earlier you talked more about the mesh and how that's going to really help advance the manufacturing industry. I know that people online can't hear me because I don't have the mic. So
right.
Their question, just give us a little more explanation about that.
So the question was about kind of mesh technologies, and there actually has been a lot of hype in the blockchain world here recently. One of the an up and coming star in the world is this coin called MIOTA, which stands for Internet of Things. Their blockchain is a rather new implementation of the technology, and it's a mesh network where you basically have a bunch of different devices. They can be little Arduino devices, right? They can be little Raspberry Pis, but they're all communicating with each other. And I think the mesh network in a manufacturing space really helps when you combine that with machine learning, because you have all these devices talking to each other at all times, right? And maybe even some of those devices have the ability to make optimizations kind of within themselves, right, in control systems. And so maybe you can aid in that optimization of some just-in-time process.
That's I mean, I still find the mesh fascinating, and especially as it starts connecting IoT. I think the limits of IoT, especially from what we've seen, are endless. And once that really starts getting integrated, as 5G starts coming online, um, I just can't wait to see a world where all those things start playing together. That being said, I think one of the things that are still critical for all of these things is mobile technology. And Phil, I know you're working on a lot of these projects. Mobile from a visual standpoint, right? Interacting with the backend processing is still connecting a lot of these new technologies or the actual processing of data. And it's a better way to get real-time data as you walk through machine shops or warehouses. How do you see mobile technology interacting with older manufacturing equipment built in the 80s and the 90s? I can't believe I'm saying 90s and old, but or connecting to legacy systems.
I'm older than you, so yeah, it's I mean, older systems, it costs a lot of money right now to, you know, if you're going to replace them with newer technology that have, you know, Ethernet connections or anything like that, it's going to definitely cost a lot. So, I mean, there's things you can do right now to get data out of legacy systems that don't have that. You could use protocol transfers that basically, you know, translate the protocol language, you know, into another language that other systems can connect to and they talk to. The other thing is sensors. So there's a variety of different sensors that you can measure. So temperature, barometer, you know, all different type of things. And the key thing there is, you know, to get all that data into a database or, you know, centralized data system that you can actually integrate with, that provides that, you know, decisions and provides that information to the user itself through a mobile device or, you know, tablets or a watch even. And allows them to make decisions. So if, you know, managers at night, they're at home and all of a sudden they get a notification that the temperature of a machine is gone up, they can quickly react and, you know, push something to maybe turn it off. Or they get an alert that says, you know, something's slow on production, you know, they can quickly react to it and make decisions.
So you mentioned decisions a lot, and we talked about older equipment and optimizing processes. Mike, you said you were going to come back to this, and I think it's a perfect segue into optimization, into decision making, and or predictive analysis for older equipment. What's your thought on machine learning in the manufacturing space as it relates to those three topics?
Those are great topics, and that's a huge issue. Some of those equipment last 30 years, right? They have control devices on them, proprietary data storage and algorithms. So
some of them have decades left.
Right. And it's cheaper to pay a programmer a couple of months than buy a new piece of equipment. So that is a huge challenge is getting that data. And I think it's really important to have a partner that can help you do that, because, you know, it's not just the data. There's time data flowing through. When was it in this machine and what does that mean to this machine, right? It's pretty complicated. So great point. I think in machine learning, there are like three key areas that people are using this data for. And so just to cover them at a little level of detail, one is predictive maintenance. And so what you're seeing is companies are able to predict more and more accurately when things are going to fail and use them longer. It's close to manufacturing, but I'll give you an example in oil well drilling. Apparently they drill these bits down into the earth and they're super expensive, gigantic diamond tipped bits. So the longer you use it, obviously the more value you get, but if you break it, you have to drill another hole. So how long can you use it without it breaking before you break it and have to drill another hole, which costs more than the bit, right? So machine learning can tell you those factors based on the earth and speed and, you know, the component and the density. And the key is UI. When we talk to the guy about doing it, he's like, you know, the engineer in the office wants really detailed data. The guy in the field wants red, yellow, green. Big red button, stop drilling, right? So predictive maintenance, you know, I did some research on it and I've seen different results, but I've seen companies be able to get, you know, 30 to 50% more improvement in their machines, and also about a 20 to 30% longer lifespan in their machine because they're taking better care of it, and they're predicting when problems. And there's all these models that you can use, survivability and hazard models. The second place, quality. and capacity and things like that you want to improve. And so when you look at manufacturing, depending on the sophistication of the industry, you can have a small but important impact, 2 to 10 to 20% in yield. If you look at something like semiconductors, we did a project with Micron Technology. 1% improvement in yield is worth $100 million. Right? Because they're already good at it and they're at such scale. So there they use 30,000 factors, and they look at their process through the chip, through the end-to-end process, and they look at all the interdependencies, and their goal on an annual basis is a 1 or less percent improvement, but it's still worth $100 million. Finally, it's then, if you want to talk about simulation further, you want to simulate the entire process. So back to oil and gas that we talked about earlier. When I was younger in this business, I said to one of the oil and gas guys, "Oh yeah, we do simulation. You should let us come out and talk to you." And he kind of burst out laughing and said, "We have 30 PhDs who do nothing but simulation." And what they did is they built a software factory. So they literally simulated every device in their factory, every valve, every motor, every pump, every refinement tool. And they do their capital asset planning via simulation, and they do their maintenance planning via simulation. So they're, make these choices. The valves, different things are very expensive. If I change these 3 things, what happens during this time window? And they've literally built a way to simulate the entire performance of the factory. Now, the first take of that's pretty good because you have some standard data, but the real trick is real-time data coming from those machines and being able to say, well, all these factors are continuously changing over time. Reassess that using machine learning, and that's the kind of power of machine learning, is that it can continue to ingest those huge amounts of data and kind of help you with that guidance. So
like update the simulation then, or like?
Yeah, so I mean, in a simple example, if you were manufacturing something like, okay, so back to oil and gas, and it's July versus December, it's hotter outside, things are expanding more, right? So the tolerances and the different parts are coming back through the model, and then you run the model to say, well, this is now under more stress than we thought it was going to be, this older valve, I guess, because of the heat, because of the expansion, right? Or it's changing faster than we thought it would. Now, it's not like a magic. It's not like it pops up in 3 seconds. Sometimes it takes hours to run these things using really complex technology. But it literally, the beauty of machine learning is it can continuously reevaluate a changing situation and update the guidance that it's giving you based on those changes. But again, back like a human being would do if they had unlimited time and capacity, right? They could look at it and go, wow, that's really hot. We should do something, right? But in a more detailed, complex way.
So I'm actually thinking about some of the challenges, but I'm going to come back to those in just a second. And this is a question for all of you. I had the opportunity, and just hearing you talk, I kind of think I did machine learning early in my career. I worked with one of the largest consulting firms and worked with 3 very, very large manufacturing facilities, and we optimized their entire processes. And we got the opportunity, and again, I think I was 22, 24. I can't remember how young I was, but what we did was supply chain network optimization. So manufacturing, distribution, logistics, just the whole chain. And through an optimization model, we got to run discrete and continuous processes. So cyclical processes and discrete processes. And we processed thousands and thousands of lines of data. One of the biggest challenges that I think we were just talking about earlier today was I was 22 or 24 years old, and I didn't even know what end was up. So it was fun. And then I think we got great results. I don't think, I know we got great results, but I was a 24-year-old trying to tell people in the shop floor what to do that have been there for 40 years. So I think the technologies that are in play today definitely help out with that, right? So I know mobile technology with real-time analytics or real-time decision-making helps out. Back in the day, I used to think, wow, I wish we had a better design for this or a better user experience for some of these network optimization models that we ran. And obviously, machine learning. I mean, I'm fascinated, especially now hearing you talk about the potential of really running those models now without, I guess I'm insulting myself, but without data monkeys like me basically processing it in the back end. But I'm hearing you say we still have to do that. So what's your take on using AI, and maybe you too, Phil, AI, mobile, and other systems to really process continuous and discrete models like that in the supply chain or manufacturing? Sorry.
So probably when you did that, you took labeled data, right? And you said, here's stuff we know. Let's build a simulation and then we'll run different scenarios, right? And that's a pretty sophisticated way to do it. And frankly, at the time, even within the last few years, the computational power is about what you could do with that, right? But what's occurred now is this kind of unsupervised learning, which says, simplistically, I don't really know, so math, tell me something about this data, right? And it's super computationally intensive. So you have things like GPUs, graphics processing units, people game with them. When you game, it moves a pixel on the screen. Moving a pixel is matrix math. So it turns out GPU cards are really, really good at matrix math. And Bitcoin mining. Apparently it's a guy in Charlottesville with like 100, no?
I got 100. I got 100 GPUs.
Incredible. Never buys heat in his house, just free heat for him and all his neighbors. So that's made possible a way to sort of to incorporate more data, right? And to ask harder questions and to let the system sort of start to do things. The other thing that's happened is reinforcement learning has changed. So back to your point about it going through the process. Let's say you have a robotic arm and it's working on tolerances and then stuff's coming into it and it's learning, well, if I put it exactly here, it's slightly off. Next time, put it exactly here, right? So you could actually teach the robot to learn based on the data you collect.
Just gotta communicate that to people on the floor so they don't think the robot's coming.
Yeah. The real problem is the data and the architecture, right? Is sometimes it's your system, especially old systems, I believe are not geared up to give you real-time data. So typically there's software architecture that has to occur and a lot of data management, right? Is that fair? Yeah,
That's true. Yeah, I mean, that is fair. I mean, yeah, and that's why I mentioned before, you have to have that, some sort of, conversion of getting that data out of legacy systems. Obviously the newer systems, you're able to pull data and everything like that real time, but really is, a matter of getting that data out there. The client that I worked with over the last couple of years, we've integrated some stuff and it's real-time data, which helps them manage the resources on the floor. So they have deadlines that they need to meet on an hourly basis to get shipments out the door to FedEx, to UPS, and everything like that. So supervisors can sit there and on their tablet look and see, okay, how many picks, how many this, are happening, and they can actually adjust, do some calculations, okay, I need more resources over here rather than here, and kind of start swapping. So they're able to meet those demands on a daily basis.
So want to kind of, I know it's 6:15 and I want to give you guys the opportunity to ask some questions, but challenges, they haven't changed. And before I go into the UX, but data and talent, right? Three top challenges that haven't changed in at least 10 or 15 years, probably further than that or longer than that. And really, do you think the industry is ready to adopt? So Mike, I'm going to come back to you, and Will, I think you could provide some feedback here, but data is always going to be a challenge, right? We're dealing with data that's 15, 20, or even 30 years old, probably longer in some cases. Security, hacking, people are going to try to hack a lot quicker, a lot faster. What we've seen is not that it happens here in Shaco, but a lot of times hackers are smarter, quicker, and faster at hacking the data that you try to protect. And I think that's one of the reasons blockchain's huge in my mind. But I'll let you answer that, Will. And then talent. We're talking about new technologies that are still not integrated in the ecosystem, but all of us, at least the 4 or 5 of us here, are pushing for it. So Mike, I'll start with you. But from a data security or operational perspective, what can you say about some of these challenges?
Well, I'll let you talk about the data security and the blockchain aspects. Obviously, there's a big movement towards cloud. Everyone says, well, I'm worried about security in the cloud, but cloud companies spend billions of dollars on security. It's definitely more secure than most other companies in the world. The problem is the edge. That's right. The problem is your edge or fog or whatever they're calling it, where you keep the data close to you or on the machine. And there's actually a startup down in Norfolk, we were talking about it, that's making a device that you attach to the machine, and it actually is like a hardware firewall for the device. And so the problem is, if you're going to stick your whole factory on your network and someone hacks it, they could literally shut your factory down. So if you lose like that Word document you're working on, it's pretty bad. But if you lose the whole factory, it's really catastrophic, right? So that problem is becoming very real as you have these connected machines. side is probably talent. It's really, there's a very, very big shortage of people who can do machine learning out there. And really a big component of it is, again, it's that sort of applied math with data, you know, and I think, you know, if you want to expand on that.
Sure. Yeah. So definitely from a data security side, right? I mean, cryptography is a new and kind of renewed area of study, especially applied cryptography. I think in the past 20 years we've been doing a lot of cryptography, but it hasn't been actually applied in a whole lot of systems. And so we're now we're having kind of the age where these systems are really really getting locked down with cryptography. And so you know, if you have a Bitcoin, or if you have not Bitcoin, if you have a blockchain, right, and it's storing data, you can assign rights to a particular account that holds, you know, particular data, right? Or actually even assign rights to several different people to look at that feed, almost like you would sort of an API. So I mean, yeah, I mean, it comes back to math, right? Like if you have to try to brute force one of these addresses, you have to try 2 to the 256 like exponential, right? So it's quite large. You could spend probably thousands and thousands. It's probably thousands and thousands of years trying to break into one address, right? The other piece of this is that if you have data stored on a blockchain, or even maybe it's not stored on a blockchain, but the blockchain has a pointer to like a specific database where the information is stored, you've kind of distributed out the attack nodes, right? So like if you have people trying to attack in a particular system, you don't have everything in just one database, right? You actually have multiple databases spread out throughout the network, which can actually be public since it's protected by cryptography, that can run your system, right? And so if you take one of those nodes down, that's bad, but it's not catastrophic. Right?
That's incredible. I still don't know what blockchain is, but it just sounds really cool. No, it's just incredible. So as more IoT devices come online, as more technology comes online, and you and I talk about this all the time, it's just I think blockchain is going to become essential. And once we stop talking about it as blockchain, I think that's where we're in a time when it actually is mature and ready to use. But for now, it just sounds unbelievable, too good to be true. But I kind of want to wrap up with one more question, and then open it up to all you guys. All of this stuff is just fascinating, and I think one of the things that I see a lot of our clients take more seriously is really the user experience and design. And when I talk to manufacturing clients, and refer to user experience and design, they automatically go to product, right? And so they have this consultant that's doing software, and I'm talking about user experience and design. And first of all, they always combine it into one term. And the second thing they do is ask me why I'm talking about their product when I'm really talking about the software. And Mason, I know you have strong thoughts about that, and I'd love just your opinion on what do you think user experience and design could do, not only from a product perspective, software product perspective, but from a differentiation perspective, from a competitive perspective, and maybe even from a safety perspective.
I think that there's all this like awesome stuff happening in technology. Like you have all this IoT stuff, you have all the crypto stuff. Well, no, but like you have all these crazy efficiencies, and like you're gonna have this curve of like sure, when you were going in consulting at 22 or 24 or whatever, and you came in and then you changed everyone's work day after you came in, I imagine, right? When you came in, you came in, you did process consulting, their days changed. Like you came in and that changed. Well, now with like the IoT stuff, like you're gonna be able to learn, or machine learning, you're gonna be able to learn new efficiencies all the time. So stuff's gonna change all the time. So I think from that standpoint, you're gonna need just quality design to communicate those changes, because if it's gonna change so much rapidly, we can't just have someone come in and tell you to do it. Like the software's gonna have to tell you how to do it. How's your floor map plan gonna change? Is that surface on my phone? Is that surface on a tablet? Is that surface on a Bitcoin? Nope. No, sorry.
Surface on Bitcoin.
You know, I'm trying. So I think that like just the discovery process is so important, and that's something that we try to do a lot, is getting in and understanding who are the people working in the factory? Who are the foremen? Who are the stakeholders? Who are the executives? And like understanding all the different points in that process so that when we're producing things that are going to leverage all this really powerful technology, we're doing it in a way that everyone in the company can benefit from. And that's just from talking to people. Like that's just going in and I mean, my undergrad was in journalism, which is oddly relevant for this. But like just going in and be able to like, kind of like essentially create stories for all these different people so you understand their process and understand how they're going to use stuff. Because then all this awesome stuff, like, and I was joking earlier, but like, this is really powerful stuff. Like, it's how do we make it just as semantic as possible, and usable as possible. And I think that's where, like, with the IoT stuff that's going to come in, like, being able to get that out there. Does that answer your question?
Can I add something really quick? So the truth is, like, blockchain is like machine learning, in that it's going to tell people something that they're like, well, that's neat, but I don't know what you're talking about, right? So if you present that UI, like, here's a decision tree, here's a bunch of leaves and nodes, people are like, okay, I don't know what that is. What does it mean? It means that this has been categorized this way, and therefore you have to take this action, right? So the better you can take this complex thing and simplify it for an end user to adopt without having to dig so deep into it, it becomes so much more usable and valuable. So I think that's a really good point. But the challenge is now that things are getting more complex that you have to simplify, right?
Right. I think one thing's really interesting too is that language is really important now. Like how you're like the text itself, and you're seeing this big advent of like what is the copy in this, and it's always been super important. But like surfacing stuff in one sentence, two sentences, but a machine has to craft that. Like, well, we have to create rules for it to write usable sentences that you can actually benefit from. Because if I can get it in a push notification or a one sentence like toast message, that's really valuable. But if I have to dig through like 10 spreadsheets, I'm an executive or whatever. I'm not. I got stuff to do. I got stuff to do.
So time in mind, I always run out of time to ask all my questions, and I hope you guys could stick around just for a little bit to answer at least my questions. But more importantly, anybody else out here, does anybody online or here in the room have any questions for any of these guys? Oli, do you mind?
Oh, hi, thank you. So I have a question as far as when we talk about the industrial revolution, as far as with the aviation community, you talk about complexity. One thing as far as like, 3D printing and printing parts, when you talk about like airplanes and whatnot, how do you deal with the material characteristics and like, as far as capturing that data in order to be able to kind of 3D print those types of parts? Have you guys seen anything happening in that space? Or with manufacturing, I guess, really complex type parts?
I haven't seen it in airline. I mean, part of the reason I think is the carbon fiber and all the complex materials are hard to 3D print, but I have seen it in other industries. And there is a movement to say, like, okay, so in some utopian place, my machine has a problem. I need a part that I can fix it. I'm going to push a button and license the design for that part and print it myself right here and go fix that before it breaks. So sure, that's certainly something that in the future is definitely going to happen. So as opposed to buying those parts and keeping them online, you're actually licensing the rights to print it, right? And doing it real time, so that now at scale in manufacturing, I'll leave it to smarter people, but certainly all the parts and the inner workings of planes are there. The other thing that's interesting about airlines is there's a real problem in data capture. We never solved it, but there was a company, and this is in my past life, down at the University of Georgia, and they were hooking all these sensors up to jet engines, and it was like throwing off so much data, they had no physical way to ingest it. It was like throwing off like 30,000 terabytes a minute or something. It was really incredible. The problem they had was using machine learning to find the failure point. They couldn't get a time window short enough to find the break, because they couldn't capture the data at that level of detail. So it was like a totally different challenge in the data management of it. Was like, this is really big data, right? We don't even have a physical way to ingest it. So lots of interesting problems out there in airlines.
So I'm really not going to answer your question, but I know that the industry is so regulated that having something like 3D printing is going to become extremely difficult. And as Mike said, the complexity of using carbon fiber or any of those lightweight materials strong. lightweight materials and combining it with 3D printing. I just don't see it being a possibility in the near future. It's probably a couple years away from my perspective, at least. Being that we're saying a couple, and with the way technology is turning, it's probably like 6 months away. But on a serious note, I think the fact that the industry is so regulated and there's a lot that goes on before any of those parts get processed, and the sheer volume, right? So 3D printing isn't really in a position for volume yet. It's very specific for small pieces, for OEM pieces, for a bolt that breaks or a nut that breaks or something like that. I just don't think it's ready for the airline industry right now. Yeah. You're done. Yeah.
About like what could be cool. I don't do a lot with airplanes, but I deal with carbon fiber in boats a lot because I'm a rowing coach at VCU. And one thing that I was able to do recently for an athlete, for a boat, was I was able to take a picture of a component for the shell, and we were able to 3D print the component off the picture. With shoot, what was the software? But basically, it could do the measurements in the photo, and then I was able to, and boat parts are very expensive. I was able to print it at VCU and have the part come in and get the boat on the water the next day. So I'm not saying that's on airplane necessarily, but like there's a hint of like I was like, because sometimes you're like, man, we're in the future, and I really felt like that was
pretty cool.
Any questions online, Ilya? Any other questions? So that being said, any final or closing comments from any of you guys? Oh, yeah.
Yeah, it seems that AI is going to end up taking over the UI, the more, in the future. And being the 65-year-old manufacturing guy, it seems that millennials just need some kind of entertainment color process in order to be, productive and, functional. Well, my question is on blockchain. I've been following Bitcoin, since it was like $20. I never got in. I hated the word bit, 8 bits to a byte. And I didn't like the word coin. And there was a guy that I've been following. He bought one pair of socks for 3 Bitcoins, and today it's $12,000. There's a new blockchain called EOS.io. Do you know that? Like, they just came out with 2.0. You know those guys. You have any comment? No? It sounds like they're going to own they're going to control the world with this, and I can't buy any of their tokens as a U.S. citizen.
I try not to make a habit of commenting on different products publicly, but I will say they are extremely well funded. Right, they're running this year-long ICO. They're going to be probably one of the most well-funded blockchains to exist. I've met the CEO, the CIO in person, and they seem like very capable, smart individuals. Dan Larimer, this is his third time's a charm sort of blockchain, right? He's got Steemit and he's got BitShares, and those were developed years ago, right? And they're both very successful. So I wouldn't bet against them. I'll tell you that much.
Any closing comments, remarks?
Just gonna walk around and do the whole thing. So we have a question online from Sheila, and it's for the whole group. So based on your recent client projects, has the adoption of these mobile technologies been difficult for those on the manufacturing floor?
Question for Phil.
Actually, it's gone really well. As I mentioned before, like, just working with the client over the last couple years, it's a young workforce on the floor that this particular client had, and they're used to phones, high school, college, and everything like that. So coming into the place and working with a tablet with good UI and user experience, they're able to, it's less training time, adaptability. But also even for the older generation, in the company, the supervisors, the leads, taking the tablet, they're used to working on their desktop to get the information, and here they're given a tablet, with different UI experience, but now they're able to walk around, go on the floor, and make their decisions, mobile.
Yeah, I've seen it also. It sounds strange, but Jim Beam makes liquor, so they manufacture whiskey and vodka and a whole bunch of other stuff. And so they arm their sales force, so pushing out to the supply chain, not directly, but it does feed back in. Mobile devices that they can sit with people like the folks who buy for all the Chili's restaurants, or for grocery chains in non-regulated states. And what they do is they sit with them and they run these models that say, hey, based on your location, places like this in similar locations have these other 3 products. And if you had them, we think you could make this much money based on your volume. Right? So the way that worked before was they would go in because they know the local market, and they would go, you need 2 more tequilas, right? Just because that's what they thought, right? Right. Now what they do is they base it on similarity matching between other stores who successfully are selling products they don't have, and then they tie it to their volume. And what that does is it feeds back into the supply chain for demand planning, for ordering and for their mechanism. So I've seen really good success because it's generating value.
So any additional questions? I'd love to keep on going with this conversation, and I know we're running out of time here, and I want to give all of you guys some time to actually talk to these guys here. But first of all, thank you so much for participating. I hope we continue doing these kind of things. Will, thanks for coming back a second time, and Mike, I hope you come back a second time as well. Phil, Mason, you're kind of stuck here. Obviously a big thanks to Nelson and Olya who helped plan this, and the rest of the team here at Shaco. But if you guys did like this and are interested in learning more, our next session is going to be on distribution and logistics, and we're going to talk about how mobile applications, hopefully machine learning on the blockchain, are impacting the distribution industry and the logistics industry. So not sure if we'll have the same people, but hopefully we do. If not, we'll have some other great people talking about that kind of stuff. And last thing, join us next week, right? Next week, the 12th, for the 2018 forecast. Yeah, so on the 18th, we're going to be basically handing out our predictions to mobile technology in 2018 and beyond. So if you guys want to stop by and just join us for a beer, feel free. If not, we're going to post it out on YouTube again. So thank you very much for joining.